This instrument is very versatile. It can show the path of any celestial object across the sky from any observer's point of view on Earth. Now, the axis of the globe points at the North Star and is adjustable for any position. So you would simply adjust this axis upward if you were in Seattle and downward if you were in Guatemala. Now right now I have it at about a 30-degree angle, which is going to show what people in Houston would see. And let's start with the most important object in the sky, which is the sun. Now as we're shooting this video, it's almost summer solstice. So I have the sun in the summer solstice position on the ecliptic. The outer ring here is the ecliptic. And what the ecliptic is it's a simple model for understanding the annual changes in the position of the sun. At summer solstice, the sun is in its highest position on the ecliptic. And we see that it rises in the northeast, travels across the sky on a high path, and sets in the northwest. And this is the highest position, the highest noon position of the sun that we see in the course of a year. Now, as the year goes on, the sun moves slowly backward along this ecliptic. So, for example, in September, at the fall equinox, it would be down in this position. And we would see the sun rising directly east, traveling across the sky on this path, and setting directly west. Now notice what's interesting about this path is that the night and the day are exactly half turned. In other words, they're exactly the same length. So it's 12 hours, the sun spends 12 hours above the horizon and 12 hours below. That's why we call the spring and fall positions the equinoxes, because equal nights and days. If we go further back, now we're at the winter solstice position, and you see how radically lower the sun is in the sky. Most people don't fully appreciate this, how much the sun varies in the sky over the course of a year. But with the horizon globe, you see just how much difference there is between the winter and the summer positions of the sun. The noon sun was way up here in June, and in December it's way down here. The difference is more than an eighth of a circle, more than 45 degrees. So the sun takes this very low path across the sky in the winter time, and notice it sets earlier. Before you get to half a turn, the sun is already setting. So the days are much shorter in the winter, and the sun stays much lower in the sky. And you see its exact path across the sky. And as I said, for any latitude, the globe is adjustable. You can see exactly what the sun does from any position on Earth. And you can tell the length of days and the exact path across the sky. So when the student reaches a later stage in his education, he will learn that this ecliptic path, which is the annual variation in the sun's path, is explained by the Earth's orbit around the sun. But that's not where we start. We start simply by understanding the observations, and then later when the student gets to the point where he's ready to understand the evidence for the heliocentric theory, all of these observations become the evidence for that theory. But without understanding the observations first, the student is left in a position of not ever being able to get a first-hand understanding of the theory. So the sun moves in this relatively simple way, but sadly it's a simple fact that we're exposed to on a daily basis throughout our lives that most college graduates today still don't understand.